Hi students, here's Spiral Review for Spiral 8. First off, we got to find the reference angle. In looking at our graph, our reference angle is defined as the angle to the closest x-axis. And if I'm going around the circle, we've got 10 pi over 3. I'm going around more than once. If I take 2 pi away from this, this is the same angle as 4 pi over 3. And if going around to here would be to pi, that's 3 pi over 3. That'll leave me with 1 pi over 3 left over. The reference angle there would be pi over 3. For number 2, we've got to give the requested ratio. We're looking for cotangent of theta. And in looking at this, let's make a triangle. So we've got 2 root 3. And by the Pythagorean theorem, this is going to come out to be a hypotenuse of 4. Cotangent is going to be the reciprocal of tangent. So tangent of theta is going to be 2 root 3 over 2. Cotangent of theta is going to be 2 over 2 root 3. For number 3, if we're given this information, this tells us two things. The first is that since sine is 4 root 3 over 7, that sine of theta is positive. That means that y has to be positive. And if cosine of theta is positive as well, that means that x has to be positive. That tells us what quadrant we're in, which is going to be quadrant 1. And sine is going to be opposite over hypotenuse. So we've got 4 root 3 over 7. Finding that third side, we're going to Pythagorize, and we've got 49 minus 16 times 3 is 48. This would be a side of 1. For this, we'd get cosine of theta is 1/7. We've got tangent of theta is going to be 4 root 3 over 1. Secant of theta would be 7 over 1. Cosecant of theta would be 7 over 4 root 3. And cotangent of theta would be 1 over 4 root 3. The next part, we got to do some conversions. Going from degrees to radians, we have a couple different ways that we do this. The first is to multiply by a conversion factor, pi over 180. And when I do that, we get 25 pi over 18. A second way would be to set up a ratio. So 250 over 180 is equal to x over pi, because 180 and pi mean the same thing. This is going to reduce to 25 over 18. To get x by itself, I've got to multiply by pi. For the next one, going from radians to degrees, I could either do this as a conversion factor times 180 over pi. And when I do that, that cancels to get 30. My pi's cancel out. 23 times 30 is going to be 690 degrees. I could also set this up as a ratio. 23 pi over 6 over pi is equal to x over 180. My pi's cancel. 23 over 6 times 180 would be 690. Next up, we got to do some graphing trig. And when we take a look at this, I'm going to identify pieces here. We've got our midline, and that's y equals 1. We've got our amplitude, and that's going to be equal to 3. So I'm going to start off by drawing those in. So midline, y equals 1. And then we're going to go up 3 from there. 1, 2, 3. And then when we do that, we have a nice set of bounds to work with. We're going to then go for our first point and last point. 4 theta minus 3 pi over 4 is equal to 0. And that's going to give me theta is equal to 3 pi over 16. That's my starting point. 3 pi over 6. Ooh, sorry, that was supposed to be on top because this is cosine. So just as kind of a side note here, the cosine shape is going to look something like this, where midline goes through there. So my first point would actually be up here at 3 pi over 16, comma, and that would be 1, 2, 3, 4. All right. Finding the endpoint, we've got 4 theta minus 3 pi over 4 is going to be equal to 2 pi, because that's my ending value. When I add those together and then divide by 4, so that'd be 3 pi over 16 plus 32 pi over 16 is going to be 35 pi over 16. So that's going to be my other point. 35 pi over 16. And that would also be at a height of 4. Exactly in between those two, 35 plus 3 is 38, divided by 2 would be 19 pi over 16. And that'd be at negative 2. And then in between those two, 19 plus 3 would be 22, so that'd be 11 pi over 16, comma 1. And then we'd have the opposite one. 19 plus 35 is going to be 45, 54, 27 pi over 16, comma 1. So my shape would be something like this. Looking at our next one, we've got to write a possible equation. And I'm going to go for all these different pieces. So we've got a midline. It's a negative 1. We've got an amplitude of 2. And to find the period, I'm going to count the distance from peak to peak. And that's going to be 3 pi over 4 minus pi over 4 is going to be 2 pi over 4. So period is going to be 2 pi over 4. Then a phase shift, I need a starting point. I'll use cosine. So my starting point would be at pi over 4. In looking at this equation, we're looking at y is equal to 2 cosine 2 pi over the period is going to be our b, which is going to come out to be 4. We're going to have x minus pi over 4, and then minus 1. Looking at trig models, I'm going to take a look at the top and bottom points of my graph to figure out where my midline would be. That would be at 9 and, I don't know, maybe 2. So that would be at value at negative 1 and positive 3. Exactly between those two, I get a midline value that's equal to 1. I can also get the amplitude from that by looking at 1 going up to 3 would be an amplitude of 2. As far as a period, I'm going to take a look at how far these two bottom parts are apart from each other, because I can see those pretty clearly. And going from 2 to 16, we get a period of 14. And then finally, we're going to go with phase shift. I tend to like starting at the top because I like cosine. It's a little bit easier to write with. So if I do a phase shift of 9, because that's the x value there, then we're good. This gives me a model of y is equal to 2 cosine. Period is 14, so we're going to do 2 pi over 14, x minus 9, and then plus 1. I don't have to use that to predict anything, so I am done. And then finally we have a curve here. I'm going to take a look at my transformations. My first transformation is the x minus 3. That means we're going right 3. And then I've got a plus 2 after, which means we're going up 2. All right, so 3, 3, or negative 3, 3. We're going right 3 and up 2. My next point is at negative 2, negative 2. We're going right 3 and up 2. My next one is at 1, 1. We're going right 3 and up 2. And my last one is at 3, negative 2. We're going to go right 3 and up 2. So my new graph would look something like this. All right. For z of x, so that's the original function. And I'm going to write original here. The domain would be negative 3 to 3. Those are my x values where this function exists. The range, the lowest y value is negative 2. The highest y value would be 3. X-intercepts, I've got 2 of them. Actually, I've got 3, I'm sorry. So it's going to be at, I don't know, it looks like negative 2.5, 0, and 2. A y-intercept, I only cross once, so that would be at 0. It's going to be increasing. That's this part in the middle. And that's going from negative 2 to 1. It's going to be positive. That's this part and this part. So I've got 2 intervals, so negative 3 to like negative 2.5, let's call that. That's going to be in union with the interval from 0 to 2. My negative intervals, I've got 2 of those as well. We're going from negative 2.5 to 0. And we're going to say that's in union with going from 2 to 3. We've got a maximum at y equals 3. And a minimum, we've got 2 minima at y equals negative 2. And finally, we are decreasing for this segment and this segment. So that's going from negative 3 to negative 2. And also from 2 to positive 3.